Hello, my name is David Fox and I'd like to thank you for taking this class on networking fundamentals. Now before we get started, a few class notes. Once you finish a chapter, you'll need to complete a short test before moving on to the next chapter. Now at the completion of the course, you will receive a certificate that you can submit for recertification credits. Now if through the course of you taking the class you run into any problems, you can always email us through the email address listed in the class notes. The purpose of this class is to give you an introduction to computer networking for entertainment and architectural lighting. We'll first take a look at the wiring and connections that are used by ETC and throughout the industry. Then we'll examine a few of the components that are used for a lighting network. We'll discuss network addressing and the methods that ETC uses for addressing network components. And lastly, we'll delve into wireless communication and talk through network troubleshooting. So what is networking? Networking is communication between any two or more devices that are typically referred to as nodes. With a network, you integrate devices from numerous manufacturers and create a common language they can all use to communicate with one another. This communication typically takes place over a wired infrastructure. When planning a network, the best practice is to design it to be expandable in a simple and affordable way so you can easily add new devices. This can be done by adding network ports in more places than you're going to need them at the initial commissioning, or by pulling additional wire to each location to allow for future plugs, or choosing infrastructure hardware that can be replaced as technology changes. All of these factors combined are the basics of all computer Ethernet networking. So what is Ethernet? Ethernet is a term used to define a group of computer network technologies for local area networks, also referred to as a LAN. It includes a number of wiring and signaling standards for both the physical layer of a network as well as the common addressing format to make sure devices work together. Now it's important to remember that Ethernet does not define the information that is communicated, but focuses on how that information gets communicated. Now most modern computer networks use the IEEE 802.3 standard created by the Institute of Electrical and Electronics Engineers as the founding block of what is considered Ethernet or a building network. Let's begin by looking at one of the most important and normally overlooked aspects of a computer network, the wiring. Networks are wired using cable that is referred to by a number of names. Its full name is Unshielded Twisted Pair Cable, but you might hear it referred to as UTP or by one of its specification names, Cat5, Cat5e, or Cat6. These different numbers refer to speed or data, which we'll talk about in just a moment. Regardless of what it is called, it is a jacketed cable containing 8 solid 24-gauge wires twisted together in pairs to give you 4 pairs of 2 wires each. Each pair contains a solid colored wire and a white banded complementary wire. UTP cable is inexpensive to buy, and it's easy to install compared to some of the specialty cables used in a modern lighting system, like DMX. The actual characteristics of the wire inside the jacket will determine speed and transmission type, the most common version being 10/100 base T. Printed on the jacket is a letter and number code so you know what kind of wire is inside your system. Let's take a deeper look at that letter number code. First, you're going to see a specification category, 5, 5E, 6, or maybe 7. Then a series of numbers, and then printed you will either see base or broad, followed by a letter. Now the numbers refer to the transmission speed in megabits per second. Base or broad refers to the signal type that the wire is designed for. Baseband, which is what you will typically find inside a closed lighting network like a building or a lighting system, uses the entire bandwidth available in the cable to transmit a signal. Broadband, which you will typically find in open networks, like a cable company providing internet to all the houses in a neighborhood, is designed to see many small independent signals broken into multiple packets. The next piece of code is a letter which determines the type of wire. Typically, this will end in a T, indicating twisted pair wire. With any of these cables, the maximum distance between nodes on a network is 100 meters or 328 feet, and this can be easy to find because typically there are foot markers on the wire that repeat every 100 meters. We'll talk more about wire and segment lengths, as well as network design when we get into our topology chapter later. At both ends of the cable, the wire pairs terminate into an 8-position modular connection referred to as an RJ45 connector, or registered jack number 45. Per IEEE 802.11 standards, female RJ45 connections are used to terminate all permanently installed wiring. Male connectors are used to terminate the ends of patch cables and extension cables. So you should never see a cable that is male on one end and female on the other. Why are female connectors used for terminating permanent wiring and placed on all devices? Good question. The main reason is because of the life expectancy or mating cycle rating of an RJ45 connection. Female RJ45 connectors average 2,500 connections before they will fail, while male RJ45 connections average 500. Or if you're working in the theater, that little plastic tab breaks about the 4th time that you've used it. My rule of thumb is to treat any RJ45 cable as disposable, and when that little plastic tab breaks, it's time to throw it away. The UTP cable terminates into the female RJ45 connections using a special tool called a punch-down tool with a 110 blade attachment. These can be found in any decent hardware store or electronics supply house. The punch-down tool is required to properly press the solid wires into the slots and secure a good connection. Male ends are placed on RJ45 cables using a special RJ45 crimping tool. Now the wire itself is terminated into the RJ45 connectors using one of two standards, either the T568A standard or the T568B standard. With either standard, the wire pairs are placed into the connector, and the individual pairs then act as your send and receive lines. They allow for proprietary communication between devices, and potentially power your nodes. And we'll talk more on that in a little bit. As you can see here, there are slight differences between the A and the B standard. At ETC, and in the entertainment industry in general, we use the T568B standard. But honestly, it really doesn't make a difference whether you use the A standard or the B standard, just so long as you use the same standard on both ends of the cable. If you're building your own cables, take care not to mix the standards on a piece of wire, because if you do, they won't pass data. Now don't worry about remembering these color codes, as you'll find this printed on every RJ45 connector. When the 100-meter distance limitations of a UTP network affects your system design, the common solution is to use a fiber optic wire. A great example of this is a large convention center where you have a network that spans the floors of a building, or a large multi-theater complex that may encompass an entire city block. Fiber communication uses a different type of cable that transmits light pulses instead of electrical impulses. A fiber optic cable is a jacketed piece of very flexible reflective glass, and this results in greater distances for data transmission from a typical UTP network. Additionally, in a fiber network there is a device called a fiber switch. This is an encoder/decoder placed on each end of a fiber line that converts the electrical pulses from a UTP network into light pulses for fiber transmission, and then from light pulses back into electrical data transmission again to go back onto a UTP network. Much like UTP cables, there is a code printed on the outside of the cable indicating speed, signal type, and transmission mode. The two most common cables used in a fiber system are 10 base FL and 100 base FX. 10 base FL, or 10 megabit baseband fiber link, offers distances of 2 kilometers in multimode and 5 kilometers in single mode. 100 base FX, 100 megabit broad-based fast Ethernet, represented as FX, offers 2 kilometers in multimode and 15 kilometers in single mode. Let's talk about multimode and single mode. Because of its high capacity and reliability, multimode is used for backbone applications in buildings and lighting systems. In multimode fiber, you have multiple light pulses that bounce along the fiber. In single mode, you have a single light pulse that travels parallel down the fiber line. When troubleshooting a fiber run, there's a few things to look at. First, remember that fiber works in pairs. You have one fiber line acting as your transmit and another fiber line acting as your receive, so you should always see two lines. If you only see one, that right there is the problem that you're running into. Next, it is possible that the pairs may be connected backwards, so if you're having problems with your fiber system, one of the first things I try to do is to swap the pairs on one side of the fiber run and see if it makes a difference. Remember, only do it on one side only. While you're performing that swap, you can also check to make sure that there is signal. Two things to remember when you do this. First, it is a light pulse, so you should be able to see it. Second, it is a laser light pulse, so you don't want to look directly at it or point it at your buddy. Point it at your hand or point it at a wall and make sure you see the light. It's a good safety practice to keep the unconnected ends capped so no one accidentally looks at them. If swapping the connections didn't work, if at all possible, get your two fiber switches next to each other and test them then. Connect the fiber lines one at a time and check their status lights. If you can't get them next to each other, find a buddy and a good communication line and talk each other through it. Also, when looking at the gear, remember that 10 based FL and 100 based FX are incompatible, so you want to make sure that your switches are designed for the same speed. And this concludes our chapter on wire and fundamentals.